Welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 238, product of array except self. Before we get into it, you guys know the drill. Please subscribe to the channel, like the video. It really helps me grow. Alright, let's read the question prompt. Given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer, and you must write an algorithm that runs in big O of n time without using the division operator. And what you don't see here is there's actually a follow-up to this question on Leetcode that says, can you solve this in big O of 1 space, where the output array actually doesn't count as space, so we'll be focusing on that solution in this video, so don't worry about that part. Anyway, let's look at a basic example. So we have 1, 2, 3, 4. So what is the product of each element in the array except itself? So let's think about it. So at the first index, that would be the product of the rest of the array, right? So 2 times 3 times 4, which is 24, right? 2 times 3 is 6, times 4, 24. Okay, so now we have 2. So what is the product of all the other elements? We have 1 times 3 times 4, so that's going to be 12. And then we also have, for the 3, it would be 1 times 2, which is 2, times 4, so that's 8. And then for 4, it's going to be 3 times 2 times 1, which is 6, right? And that's what we expect here for our answer. So pretty straightforward, right? You just multiply all the other numbers that aren't your current number and you're done. So, the most simple way to do this would just be with like a double for loop to basically just go through the rest of the array. 1 would track the current index, and then you just multiply all values that aren't at that current index, and then you set that current index at the end of the first for loop. Unfortunately, that wouldn't work because we need to do this in big O of n time, and we can't also use the division operator, right? An easy way to do this would just be to get the total product, which in this case is 24. Then what we could do is just walk through the array and then just divide 24 by the current element, and we would get the product of the array except itself. But that doesn't work because we're not allowed to use the division operator. So how can we do this in big O of n time and the follow-up which says big O of 1 space without using the division operator? So we're going to be using a little bit of a trick here, and what I want you to realize is that let's think about this. Say we have our array here, 1, 2, 3, 4, right? What is the product of the array except 2, right? It's going to be the product of everything to the right of 2 multiplied by everything to the left of 2, right? The product of everything to the left of 2. So the product here is 1 times the product of whatever is to the right of 2, which is 12. So in this case, we get 12, right? And that's going to hold true for every single element, right? For the 3, we have 1, 2, 3, 4. It's going to be the same idea. The product of the array except 3 is going to be the product of everything to the right of 3 multiplied by the product of everything to the right of, to the left of 3, which in this case is 2 times 4, and that's how we get 8 here. So that's the idea that we want to basically do with our solution. We want to essentially figure out at each point what is the product up until that point. And what we can do is we can actually fill an array with the product, right? So for example, for this one, we would say, okay, what is the product of everything to the left of 1? Obviously, there are no elements to the left of 1, so we have to set it to 1. We can't set it to 0 because obviously if you use 0, then you're going to be multiplying everything by 0, and you're not going to get an answer. So we have to set it equal to 1. Then for 2, the product of everything to the left of it is going to be 1. So our new array would be 1, 1. Then we get to 3, which is going to be 2 times 1. And the way that we're getting these values is we're simply multiplying when we're at a number. So say we're at this 3. The way that we're going to get what value we put in here is simply to multiply our last value in the actual array multiplied by the last value in our newly built array, right? So for the 3, we multiply the last value in the array, which was 2, times the last value here, which was 1, right? So we get 2. So now we get to the 4. And at the 4, remember, we're going to take the 3 because it's the last value in the array for us. And then we multiply it by the last value in this newly built array that we're building. which is, 3 times 2, which is 6, right? So now we can repeat this process for, going on the right, right? So what is the product of all the elements to the right of, 4? Obviously it's going to be 1 because there are no elements. What is the product of all the elements to the right of 3? Obviously it's going to be 4. And then to the right of 2 is going to be 12. And to the right of 1 is going to be 2 times 3 times 4, which is 24. So now what you notice is we have these two arrays. And this isn't our solution yet. But remember that the top array represents every product to the left of an element at a given index. And the right array represents the product for any index, all the elements to the right of it. So all we need to do is now multiply down these values and we will get our answer. Remember, because we said that for any point here, the product of the array except it is going to be the product of all the, products to the right of it times all the products to the left, which is what we have here in this array. So if we multiply down, we see we get 6, we get 8, 12 times 1 is 1, and 24, which is exactly our answer, right? 24, 12, 8, and 6. So that's the idea that we want to use here, right? We're going to build this array going when we go from the left, and we're going to go from the right. So unfortunately, this solution, while it works, and it would probably pass this first case here, doesn't pass the stipulation that we're only allowed to use big O of 1 space. And remember that we are allowed to have one array because we need it for the output. So we need to figure out a way to just do it with one array. And it turns out that we actually don't need the second array because we can just keep track of the product from the right using some variable. And we'll just call it prod. And we can just keep adding to prod as we go along and then multiplying the values. We don't actually need to build the array and then multiply. We can just do it as we go because we already have this original array, and we'll simply just modify the original array here instead of creating a new one. So we don't actually need the second array, and you'll see how we'll do this in the code editor just because I've been talking for a while and it's probably easier to go to the code. So that's our idea. We're going to build this array by going from left to right over nums, and we're going to basically figure out at each point what is the product of the elements to the left of it, and then we're going to do the same thing from the right, except for this time we're going to use just a variable to hold that product, so we don't need that second array and wasting space. And then all we're going to do is going to multiply that product by each index here as we go along, and then we're going to have our final result here in that original array that we built. So that's enough blabbing. That's a lot of information to take in. Let's actually go to the code editor and type this up. It's really simple. I want to say it's like 15 lines of code. It's really easy. Let's go to the editor and type this out. You'll see that this question is not that bad. All right, we're back in the code editor. Let's type this up. So remember that we need to return a list here, and we're going to need to define a variable to basically store our result. So let's define that result array. And we're just going to fill an array with ones equal to the length of our original nums. So we're going to say res is just 1 times the length of nums. So that's going to basically set up our result array. Now remember, what we wanted to do was, we had our array 1, 2, 3, 4, and we want to build out our result array. In this case, what we're going to do in the first case is we're going to go from left to right over our original array. And what we want to do is we basically want to figure out the product of the product to the left of every index, right? So for 2, it would be 1. For 3, it would be, 2 times 1. And then for 4, it would be 3 times 2 times 1. So we basically want to figure that out. And we need to basically build an array, build out our result array here by iterating over this one. So we're going to say I equals 1. And the reason we're doing 1 is because we always want to look back one element. And we're going to say while I is less than the length of nums, we're going to say that the result of I is equal to nums of I multiplied by res of I. And remember, so let's think about why this happens. So if we're at the index 1, which is this 2, what is going to be the result here? So if we have our array, which is, remember, initialized to 1, 1, 1, 1. So we have res of I is going to, so for this one, it's going to equal to whatever the previous number was in our array. So 1 times whatever res of I minus 1 was, because remember, res of I minus 1 represents the product up until that point. So we always want to be multiplying it by that. It's kind of like, it's not like a, it's, you know, we have prefix sums. This is like a prefix product. So we're basically just like a cumulative product here. So that's why we always do a look back and basically update our res of I. So, you know, we're going to do that, and then we're going to update our I here, and this is going to run while the loop goes. So if we think about, you know, what our array would look like, so obviously we don't start at 1 because obviously there is no minus 1th element here. There is nothing to the left of our 1, so we just start at the first index. So at the first index, you know, we multiply 1 by whatever the previous product was, which is 1. Then we get to 3. So now we multiply the previous number by whatever the previous product was, which in this case is going to be 1. So we set that equal to 2 now. Then we get to the 4. What we want to say is, no, this should be 1, and this one should be 2. My apologies. Then we get to the 4. We multiply the previous number by whatever the previous value was. So this is going to be 6, and that's kind of how the array would look like after the first pass, right? So now what we want to do is we want to do the exact same thing, except we're going to be going from the right now. And remember that we don't actually need to use an array for this. We can just store it in a product. So we're going to say prod equals 1. And we're going to say we want to do the same thing, but we're going to go from the right this time. So we need to start at the, you know, the length of our nums minus 2. Because remember, minus 1 would be here, but there is nothing to the right of it. So there's no point of us doing that. It's, you know, the product's always going to be 1 in that case, which is what we initialize it to. So we're going to say I is going to equal to the length of nums minus 2, which would start us here. Now what we want to do is while I is less than or equal to 0, because now we're going from right to left, we're going to multiply the product. So we're going to say the new product is going to equal to the previous value of, you know, the nums. So, nums of I plus 1. So we are now, okay, so this is the original array. This is our, you know, previous array. So the first thing we do is update our product. So now we're here. Our product gets multiplied by the previous number. So that would mean, you know, the product of everything to the right of 3 would be 1, which is our original product, times whatever, you know, the previous index was, which is 4. So now prod, you know, it becomes 4. And what we want to do now is we want to update our result, right? So we're going to say res of I is going to now get multiplied by that product, right? So res of I, this value here, it now needs to get multiplied by this 4. So this becomes a 8, and we continue through our array, right? Minus 1. And now let's go through it. So our index is now here. So now we update our product with whatever the previous number was, which is the 3. So we multiply it. So now the product is 12. Now what we want to do is we want to multiply our value here. So I think I made a math mistake somewhere. Oh, no. We're good. So what we want to do is we want to multiply our product by, you know, the previous number. The number that's at the index. So remember, we're at this index 1 here. So we want to multiply it by whatever's at the first index in this array. So 12 times 1 is going to be 12. And then we, you know, continue. So now our index is here at the last one. So at index 0. So remember that we're going to multiply our product by whatever the previous number was, which is this 2. So now the product becomes 24. And now what we can do is we can say 24 times whatever this value is. So 24. And that would be our final solution being held in this result value. So now all we need to do at the end is simply return res, and we're good to go. And I'm going to get rid of all these comments so our code can actually submit. Let me just make sure I didn't miss anything, and it looks fine. Okay, cool. So let's submit this. And it works. Okay, cool. So what is the time and space complexity? So let's think about this. Well, in our case, what have we done? We have gone from left to right over the array. So that's going to be a big O of n operation, right? Iterating over the array one time, big O of n. Then we do it a second time to go from right to left. So that's fine. That's also big O of n. So we have a 2 times big O of n here. but we know that asymptotically, this is just the same as big O of n because we can ignore those constants. Now, what is the space complexity? Well, technically, we do have this extra result array, so it is big O of n space, but because we need to return a list, there's no way to get around this. We cannot modify the original numbers or this wouldn't work. And as you can see here for the follow-up, we need to do it in big O of 1 extra space, but the output array does not count as extra space. So because we're not counting this as extra space, this is going to be a big O of 1 solution, since we can, the problem basically tells us, don't count this as extra space because you need it for the final solution. So because, we create this, but we don't use any other extra space, we can treat it as big O of 1 in the space complexity. So that is how you solve this question. It's a bit of a weird one, working with the prefix products, but once you've seen it once, it's really simple and you can pretty much easily remember how to do it. It's just like go through it on the left and then go through it on the right. The only trick to it is using the product on the way back. You could do it with another array, but obviously that would violate the extra space requirement. That solution is a little bit more intuitive, but the product one, you're basically doing the same thing. You don't actually need the product, and you would waste an extra iteration going through to actually multiply down the values. So this is the most optimal solution. This is a really popular question, and a lot of people seem to like it. It's almost got 14,000 upvotes. So definitely quite a popular one and one to know for your upcoming interviews. Anyway, that's how you solve product of array except self. I've been blabbing for way too long, so I'm going to let you go here. Thank you so much for watching. Please subscribe to the channel if you want to see more content like this. Leave a like and a comment because it really helps me with the YouTube algorithm. And otherwise, have a nice day. Bye.